Hello and welcome to Mass with Favor Olumese. I am your tutor, Favor Olumese, and today we'll be working on hexadecimal to decimal and also decimal to hexadecimal. That is our base 16 to base 10, and we're also going backward. So, okay, let's get started. In hexadecimal, we count from 0 to F. 0 to F. We count from 0 to F, where F is 15 in decimal. That is, we count from 0 to 15. When we get to, okay, let's do something. 1, 2, 3, 4, 5, 6, 7, 8, 9. In hexadecimal, our 10 becomes A. Our 10. Our 11 becomes B. Our 12 is C. Our 13 is D. Our 14 is E. And our 15 is F. Okay. So let's get started with some conversions. So let's say 1 F2. 1 F2, converting it from base 16 to base 10. Okay, so I want you to remember that we are working with base 16. So we'll do this. You'll say 16 raised to power 0. We count from 0. Yeah, we say 16 raised to power 1, 16 raised to power 2, 16 raised to power 0, 16 raised to power 1, 16 raised to power 2. So that will be equals to 1 times, that is this, 16 raised to power 2 plus F times 16 raised to power 1 plus 2 times 16 raised to power 0. Okay, so now we say 1 times 16 raised to power 2, so that is 1 times, okay, oh sorry, 16 raised to power 2 is 256, 256 plus F. Our F, don't forget, we say F is 15. F is 15. So 15 times 16 raised to power 1 is 16 plus 2 times 1. Okay. So 1 times 256 is the same thing as 256 plus, we say 15. 15 times 16 give us 240 plus 2. Okay, so we have 240 plus 256 plus 2. That will give us equals to 498. 498. So that means 1 F2 base 16 equals to 498 base 10. We can quickly check this. So we have here to be, we're converting from hexadecimal, so that is it. 1 F2, okay, so converting it to decimal, 498. Okay, that is correct. Okay, let's try another example. Okay, let's consider 2 ABC 2ABC base 16. Okay, here will be 16 raised to power 0. Here will be 16 raised to power 1. That will be 16 raised to power 2. That will be 16 raised to power 4. So we are going to be having 2 times 16 raised to power, sorry, this is not 4, this is 3, 16 raised to power 3, sorry, 16 raised to power 3 plus a times 16 raised to power 2 plus b times 16 raised to power 1 plus c times 16 raised to power 0. So we're having 2 times 16 raised to power 3. Let's get that done. 16 raised to power 3, that is 4096 plus a is 10. So we have 10 times 16 raised to power 2 is 256 plus b, which is 11 times 16. Then we have plus c, which is 12 times 1. All right. So okay, here we have 2 times 4096. So we're having that to be 8192 plus it will be 2560 plus 11 times 16. So that is 176 plus 12. Okay, so we add all them together. 8192 plus 2560 plus 176 plus 12. So our answer will be 10940 base 10. You can quickly check that. So we have hexadecimal 2ABC. So converting it to decimal, 10940. That it means we are correct. So 2ABC base 16 is equals to 10,940. All right. So now we are moving from decimal to hexadecimal. Okay, so let's consider 520. 520 here we'll make use of long division. 520. So say 520 divided by 16. Follow me. 520 divided by 16. 32. So we'll have 32. 32. Okay. Remainder. Now we need to get our remainder. So what we'll do will be we'll minus we use 32.5 minus 32. So we'll be left with 0.5. Then 0.5 times 16 for us to get our remainder. So that will be 8. So we say 32. So 32 divided by 16 will give us 2. 2 remainder 0. Okay, so we say 16, or rather 2 divided by 16 will give us 0 remainder 2. So we'll come and we'll draw an arrow. That is to signify, what this signifies that we are starting from the our first figure, or our most significant digit will be 2, and our least significant digit will be 8. So what am I trying to say? I'm trying to say, okay, 520, which is base 10, will be equals to 208 base 16. We could check that. 520, that means we're correct. Okay, let's try something else. Let's consider 10,000. 10,000. Let's convert it to base 16. 10,000. So we see dividing by 16. Okay, 10,000 divided by 16. So we have 625 remainder 0. 625 divided by 16. So we'll be having 39 remainder. For us to get our remainder, we need to remove this 39. So we'll be saying 39.0625 minus 39. So this is what we'll be left with, times 16. So remainder 1. So 39 divided by 16. 39 divided by 16, we have 2. So our remainder, to get our remainder, we'll say 2.4375 minus 2. What we'll get, we times it by 16. That is remainder 7. Then 2 divided by 16, that will be 0 remainder 2. Then you draw your arrowhead. Like I said, this signifies we are starting with our most significant digit will be 2, and our least significant digit will be 0. That means we are starting from 2, then we move to 7, 1, 0, base 16. So therefore 10,000 base 10 is equals to 2,710 in base 16. Go quickly check that. Okay, 10,000, then in base 16, 2,710. Okay, so that will be all for today. I hope you you got it. If you have any question, you can leave it in the chat box. I'll be there to help. I also want you to know that when we are converting from between other bases, it could be base 7, base 9, base 3. We still use this method. If this was to be, we still use all this method I've shown you. If this was base 7, where we had 16 raised to power 3, it would have been 7 raised to power 3, 7 raised to power 2, 7 raised to power 1, if it was base 7. And in this place, if we were dealing with base 7, the long division would have made use of 7, but in this we are making use of 16 because it is base 16 we are working on. If we're having something like base 3, here will be 3, and here will be 3 raised to power 3, 3 raised to power 2. I just want to touch on that. So I do hope you enjoyed the video, and I do hope I've been able to answer questions that may have been in your mind. But if you have any other question, please comment below, and I will be there to attend to your questions. Please like, subscribe, share this video. Thank you so much, and until we meet again, I remain your tutor, Favor Olumese. Thank you.